Ready? Go. E is approximately 2.7 Andrew Jackson, Andrew Jackson. So what is E? Where did it come from? Well, in today's lesson, 8.6a, the last lesson of Unit 8, we find out that E is often used to express the concept of the, so it's an irrational number, which means it can't be written as a fraction. But again, it is. Go ahead and make a note to yourself on your notes. It's approximately 2.7, 1828, 1828. They give you the first Andrew Jackson here, but not all of them. Also, they give you a calculus expression. This is remarkable, that you're given a chance to peek through a window into Unit 1 of calculus. In calculus, we talk about E is the limit as x approaches infinity of 1 plus 1 over x to the x. It's a little bit jarring to see this calculus notation coming out of nowhere in an Algebra 2 course. It might be a little easier on your system to see another expression for E. E happens to be exactly equal to 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus ... forever. It's an infinite series. Now, does anyone know what 0 factorial is? What is the value of 0 factorial? It's 1, and your calculator will confirm this. If you go to math, actually if you type in 0, and then go to your math menu, and go to the probability submenu, item 4 is the factorial button. So 0 factorial is 1. Remarkably, 1 factorial is also equal to 1. In fact, I can see that by simply pulling up 0 factorial and changing the 0 to a 1. 0 factorial is equal to 1. 1 factorial is equal to 1. Any ideas as to what 2 factorial is? It's equal to 2. 2 factorial, yes, go ahead.
Wait, sorry, what is it?
Well, if you want to find out what 8 factorial is, in fact, even 3 factorial, if you want to find out what factorial is, it's an operation. And to find 3 factorial, you take 3 times 2 times 1, so that'd be 6. To find out what 4 factorial is, you just take 4 times 3 times 2 times 1. So what do you expect 4 factorial will be? 4 times 3 times 2 times 1 is 24. That's right. 5 factorial is 120. And it just keeps going on like that. So, but 0 factorial is the one that has to be defined. Because 0 factorial, by definition, is equal to 1. So it's a little surprising that 0 factorial is equal to 1 factorial. Some people look at that and get confused. Because what if you divide both sides by factorial? If you divide both sides by factorial, you get 0 equals 1, which not everyone knows to be true. It's like, wow, what did you learn in school today? Oh, Mr. Royce taught us that 0 is equal to 1. Well, actually, 0 is not equal to 1. Why is it that it seems like 0 is equal to 1? Well, what's wrong with the logic here? It is true that 0 factorial is equal to 1. And that 1 factorial is equal to 1. So why is it that 0 is not equal to 1? I mean, suppose someone tried to teach the children that 0 is equal to 1, and they say, here's the proof. How would you speak into it? How would you expose the lie? How many of you are thinking, I don't think it is a lie. I think 0 really is equal to 1. Is there anyone that kind of agree? How many of you are thinking, no, I think that 0 is not equal to 1? How many of you are of the 0 is not equal to 1? So Anna, you think that 0 is not equal to 1?
Oh, wait. You mean for factorial?
No, just 0 and 1. Not 0 factorial, 1 factorial. 0 factorial is equal to 1 factorial, but just 0 and 1. Is 0 equal to 1?
No.
No, it's not. But why does this proof make it look like it is equal to 1? Did you know that division is only allowed when you have numbers? Like if you have 0 factorial equals 1 factorial as your original equation, if you go around saying, let's divide by factorial, to you get 0 equals 1. You're not allowed to divide by anything other than a number. It should be a non-zero number. So if someone says, look, divide both sides by factorial, that would be like saying sine of x is equal to 6. And to prove it, let's actually sine of, let's try this. There's all sorts of strange things that people try to do. That's sine of x equals, I'm gonna set up the original problem as sine of x equals 6n. When you divide both sides by n, the n's cancel and you get six equals 6. I mean, it's just silly talk. You can't go dividing, sine x by n and expect the n's to cancel.
Where is this on the note sheet?
Well, here, yeah, since you kind of walked in a little bit late, what we're talking about is e. And e is, by definition, 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial. So what you missed when you were out of the room was a discussion about factorials and what they mean. We looked at them on the calculator.
Will this be on the test?
Yeah, well, actually, that question, e will be on the test. Yeah, and so that's why we're learning about e. We're learning about the concept of e. E is defined in terms of factorials. And so what we have here is a situation where we can, I mean, it's not the first time we've seen factorials, but we are looking at e using calculus notation. You can also think of e as how much money you have when you take $1 and invest it at 100% interest, compounded n times per year for 1 year. And if you take the limit as n approaches infinity, you get approximately 2.7 Andrew-Jackson isosceles right triangle. Just keeps on going.
I'm sorry.
Andrew, and that's another thing that you missed when you were out, is that Andrew Jackson was first elected president in the year 1828.
Oh.
So when you take a look at our notes and you see 2.7 1828, you can say just the mnemonic device is Andrew Jackson.
I feel like that might be harder to memorize than the actual.
Well, you know what? What you could do is look at this. E is approximately 2.7 Andrew Jackson isosceles right triangle, which is a 45, 90, 45 triangle. That's just, it's the standard mnemonic device for remembering the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The first 16 significant figures of E, which is our lesson for today, it's all about E, is 2.7 Andrew Jackson isosceles right triangle. So that's your mnemonic device. If you have any other questions, just raise your hand and wait for me to call on you. So what we have here now is the natural logarithm, which is e to the x. What if we let the base equal e, which again, e is approximately 2.7 Andrew Jackson. So here's what you do need to know for the test. You need to know that log base e of x is expressed as shorthand ln x. So when you see ln x, that means log base e of x. The L stands for log, the N stands for natural. So even though we pronounce it natural log of x, it's not written NLX. It's written with N and L switched. It's written as log natural, but you say natural log. So when I say go, I'd like you to say out loud and in unison. LNX stands for natural log of x. Ready? Go. LNX stands for natural log of x. Okay, so LNX is log base e of x. And here we have the graph of y equals e to the x, which has an a value of 1. A is 1. It's like a population that starts at 1 and since E is, so just think 2.7 Andrew Jackson is a little bit bigger than 1, it's a growth graph. So here's a new parent graph for you. It's the graph of e to the x power. Contains 2 key points, 0, 1, and 1, e. 1, e is the second key point. So if you reflect that over the line y equals x, you get the graph of y equals natural log x. So there's 2 new parent graphs today. The first one is y equals e to the x, and the second one is y equals natural log x. Log graphs always contain 2 key points, 1, 0, and b, 1, where in this case, b is e, which you can see is about 2.7 Andrew Jackson isosceles right triangle, which is a 45, 90, 45 triangle. Yeah, go ahead.
Is Alana in this class?
Yeah, she's right.
Hi, could you?
So let's go on to page 2. So again, the theme for today is E, and we're doing both log base E and also exponential growth with E. So when it says ln of m times n, really what we're thinking is log base E of m times n. However, in the real world, you don't really write log base E. That's only if you're a math teacher. When you're trying to help people understand the concept of natural log. So when you see ln, you can think log base E, but usually for mathematicians and scientists, they would never really write down log base E. It's really just for teaching purposes. So I put a cloud around that to indicate, it's like a mind cloud. That's what's going on in your mind. But you don't really write that down very often. Okay, so just like the log of a product is the sum of the logs. So we write that as natural log m plus natural log n. The log of a product is the sum of the logs.
Wait, is that ln or?
That's an ln. ln is cursive. Like you can write ln in printing or in cursive. So I typically write ln in cursive, but you can also express yourself in printing. Try the second one on your own. See if you can express the quotient property using natural logs. Write down what you think it is. Sophia, what do you have?
I don't know.
Well, do you remember verbally? Well, in fact, I'll tell you what, let's try this. I want you to say the log of a product is the sum of the logs. Try saying that.
The log of the product is the sum of the logs.
Good. Do you know what the log of a quotient is?
Difference?
Yeah, it's the difference of the logs. So tell me what to write down for this one. You're hesitating a little bit. Is it because you're not sure how to pronounce that ln thing?
No.
Okay, go ahead and try it then.
Natural log minus
Natural log of what?
of m
Good.
minus n.
It's natural log of m minus, well, in fact, go ahead and pronounce this one for me. Just pronounce this expression. Make sure we're okay on the pronunciation piece.
Natural log plus m.
Say natural log of m.
Natural log of m plus natural log of m. So
Good.
it would be natural log of m minus natural log of m.
That's it. Natural log of m minus natural log of n is correct. Here's the hat rule. The hat blows off. Now it's on the ground. People are walking on it. X, natural log m. Any questions on the properties of natural logarithms, which are really the same as the properties of any other logs? Not a new concept. Happily, it's not new stuff today. We're just bringing in a new number, which is about 2.7 Andrew Jackson. 2.7 Andrew Jackson. All right, so it says write each expression as a single logarithm. Well, 2 is a hat. Let's put it on 12's head. So the first move is to put the hats back in place. If you see hats on the ground, put them back on the head. And by the way, 12 squared is 144. 12 times 12, 144. Well, can I go any further, or is this as far as it can be simplified? Well, we better be able to go further, because the instructions say rewrite this as a single logarithm, log base e. So, what would my next move be? So what do you think? Owen?
So we divide 144 by 9, so natural log, parentheses, 144 over 9.
Yeah, and since 144 divided by 9 is 16. Natural log 16 would be your final answer. I'd like you to try letter B on your own. Try letter B. When you're done, you can look up at the screen, see if we agree. What did you get as the final answer for letter B? Let's go with the money on this one. Natural log of 8 is correct. Good job. Any questions on letter B? All right, continuing on. Try part C on your own. Just put the hats back up in position. Then use the fact that a sum of logs is a log of a product. Yeah, Lauren. So, sometimes people wonder what's going to be on the test. What's going to be on the test is the stuff that's in the examples and in the homework and on the review sheets. Any questions on how to get natural log of xy cubed? What's the first thing that you would write down on letter D? Help me with that, please. Daniel.
Well, you would write natural log of 8 squared minus natural log of 4 cubed.
Good. So 2 and 3 are exponents. Notice that 8 squared and 4 cubed are both 64. So when you look at the problem in this format, it seems like the answer has got to be 0. And, oh, by the way, some of you, so 0 is the answer. But keep in mind that the directions read, write it as a single logarithm. So even though the answer is 0, if you're really going to follow the directions, instead of writing the answer as 0, you're obligated to write natural log of 1. Now, the natural log of 1 is equal to 0, but they didn't ask you to evaluate the expression. They asked you to rewrite this as a single logarithm. So that's why the answer is natural log of 1. Let's pause here. Any questions on page 2? Yeah.
So the answer is natural log 1?
Yeah, natural log 1 is 0, but they didn't ask for the value of the expression. The directions read, write the expression as a single logarithm. Okay, let's go to page 3. Now, we have invisible bases here. For using the arrow thing, it's not a bad idea to make the invisible visible. Natural log really means log base e. So go ahead and try that first one. See what you come up with when you try to solve it. Okay, well, let's see how we're doing here. If you make the invisible base visible, then we've got EF is the code here for exponential form. So that's a signal that it's time to use the arrows. Exponential form will give us 2x is equal to something. Jay, what would 2x equal in this case?
Natural log E.
Actually, when you do the arrows here to change it from log form to exponential form, there won't be a log there anymore.
So it'd be E to the 10th.
It'll be e to the 10th power. So when you put this in in exponential form, you get 2x equals e to the 10th. And then you can do an m1/2. You get x equals 1/2 e to the 10th. Now, what if you're thinking d2 instead of m1/2? Well, then you'd probably write e to the 10th over 2. Both of these are acceptable answers. Both of those are full credit. Any questions on letter A? All right, Jack, could you tell me what you would get for exponential form on letter B?
3x plus 4 equals 8.
E to the 5th power is correct. So we're going to finish up by doing an S4 and M1/3. So let's see if you can do those 2 steps on your own. Now I came up with 1/3 e to the 5th minus 4/3. If instead you wrote it as e to the 5th minus 4 all divided by 3, then that would be full credit also.
Do you have preference over 21 on the test?
No. All right. Now, letter C and D. Yeah, question, go ahead.
On number, or letter A.
Yeah.
You do 1/2 E to the 10th. You just re-explain, is it just because you divided by 2, so that would just be, once it goes over and combines with E to the 10th, that would be 1/2.
Yeah, I mean, you could, to show the harmony between these two answers, you could think of e to the 10th as e to the 10th over 1.
Right.
And so when you multiply these two together, you get e to the 10th over 2. So that's why I would accept both of these as correct.
Right.
Okay? So letter C shows up twice. It shows up as letter D. So we're going to do this 2 different ways. And interestingly, we're going to get 2 different solution sets. See if you can figure out why. Bit of a mystery here. We're going to, first of all, put this into exponential form. So write down what you think the exponential form would be for letter C in the form 3x squared equals something. What would that something be? Mia.
I don't know.
You know what you can do to help you see that? What you can do is make the invisible base visible. And do you ever do the arrows? Like when we talk about the arrow thing, do you ever draw those arrows? Mm-hmm. So, go ahead and draw the arrow there. That will tell you what 3x squared is equal to.
E to the 4th.
That's correct. It would equal e to the 4th. So that's your first move, is to use the arrow thing to get 3x squared equals e to the 4th. Next, let's go ahead and do D3. Instead of m1/3, we can divide both sides by 3. That gives us x squared equals e to the 4th over 3. And then, Gerald, would you please tell me what the DSR code would indicate our algebraic work would be? So you got x squared equals a number. So according to the definition of square roots, what should x equal?
Plus or minus square root E to the 4th over 2.
Yeah, or I could do the square roots individually. That's good, you remembered the plus or minus. And, I mean, honestly, that's a place where could be the difference between an A and an A plus for many of you on Friday's test, is whether or not you remember to put in the plus or minus. Now, we can simplify this further. First of all, rationalize the denominator by multiplying by 1 in the form radical 3 over radical 3. So it looks like there's 2 solutions. X is an element of the set. One solution is e squared radical 3 over 3. The other solution is negative e squared radical 3 over 3. Two solutions, and if you plug them in, both of them, even the negative answer makes the original equation true. Wait, what's e again? Oh, the calculator knows. It's 2.7 Andrew Jackson. Andrew Jackson. Jonathan?
So I just confused, how do we get from multiplying square root of 3 and then we get e?
Well, the square root of e to the fourth is found by taking half of the exponent. Half of 4 is 2. Probably remember that back in unit 7, we would do things like, the square root of x to the 16th, we would say is x to the 8th. How do we know? The square root is an exponent of 1/2. Now, they're asking us to take a different approach to solving this equation. Unless there's any other questions whatsoever on part C. Okay, now for a little bit of a surprise, look at what happens when we use log properties. What if I think of this as a log of a product? So I can rewrite it as natural log 3 plus natural log x squared equals 4. I mean, that is legit because the log of a product is the sum of the logs. 2 is a hat that flies off x's head and lands on the ground. People are walking on it. It's kind of upsetting. But I'm solving for x. So let's subtract natural log 3 from both sides. By the way, this is, could say hat rule, but hat rule is just a way to simplify. Now I'm going to subtract natural log 3 from both sides. S ln 3. So when you subtract natural log 3 from both sides, you get 2 natural log x equals 4 minus natural log 3. Dividing both sides by 2. Actually, let's do an m1/2. Let's multiply both sides by 1/2. So you get natural log x equals half of 4 is 2 minus 1/2 natural log 3. Use an m1/2. And now, let's put this in exponential form to get a final answer of e. I should actually say x equals blue. So the final answer appears to be x equals e to the 2 minus 1/2 natural log 3. And this is surprising because you're like, wait, Mr. Royce, I thought the answer was e squared radical 3 over 3. Is math broken? How can x equal e squared radical 3 over 3 or a negative e squared radical 3 over 3 on one hand? Here's 2 answers. And here we have something that looks completely different. Well, if math is broken and word gets out, people start clicking on that, that would be clickbait. If anything's clickbait, that would be. Math is broken. Across the globe, students would be dropping out of math classes, screaming, I'm free, running through the meadow, hugging each other. Wow, what an event. Is this what we just discovered today? I told you it was going to be a little surprising. Have we just discovered that math is broken? Well, let's go to the calculator. Let's type in both these answers. See if they're really different. Okay, here we go. E squared radical 3 over 3. Let's type it in. E squared radical 3 over 3. I'm going to type in E squared. And I'd like you to do the same. Get used to using your E key. E squared radical 3 divided by 3 comes out to be about 4.266. That's our first answer. Bethany, do you have your calculator? Lauren, do you have yours? Yeah, just take it out. Type in e squared radical 3 over 3. That's what it appears the answer is. And it is. I'm kind of nervous right now. My heart's beating a lot faster than usual. It's like, Am I gonna be the one who breaks the news that math is broken? What am I gonna do for a living? How am I gonna support my family? No
Make
one?
YouTube videos.
Anyone? Make YouTube videos? Okay, that's not a bad idea. Okay, so there's hope. There's a backup plan. How about this one? E to the 2 minus 1/2 natural log 3. Let's try it. E caret, and what's it supposed to be? I've got it right here. It's gotta be 2 minus 0.5. Look, there's an ln button on your calculator, natural log 3. Well, it's a moment of truth. This thing, which looks completely different, if this comes out to be 4.266073528, then maybe math is not broken.
Where's the L?
ln is right under the log button. See, under log, it's ln. That's for log base e. So 2 minus 0.5 natural log 3. I don't know if I can bring myself to press enter. Is there anyone willing to come up here and press enter for me? Daniel, come on up. So Daniel's going to reveal the truth about the future of mathematics. Here we go. Click enter. It's not broken. It's really true. You can do it both ways. Hello.
Alright.
Although there's still a bit of a mystery.
Wow.
Math is still a thing, everyone. Just for those of you who were gone for a little while, just want you to know, if you're just recently coming back, math is still a thing. All right, so yeah, I know e squared radical 3 over 3 doesn't look anything like e to the 2 minus 1/2 natural log 3, but they're the same value. But it still raises the issue of why does this approach give you 2 answers and that approach give you only 1 answer? Well, there's a reason for that. When you use this log property, you actually change the domain. When you brought the hat off, now the domain is positive numbers only. But when the hat stayed on, it was all real numbers except for 0. So that's one thing to learn about this log property, is that it can change the domain of the function. So the correct answer is actually the one that has 2 solutions, not the one that has 1 solution. Sophia, do you have any questions on that? You okay? All right, let's go to page 4. Let's wrap up the lesson. On page 4, these go pretty quickly. 2.7, 1828, 1828, 459045. Huh, I remembered it. Okay, so solving these for x goes super fast because look, you just put it in LF, log form. So if you're gonna solve this for x to say that that is log base e of 15 equals x, that's fine, but don't leave it like that. Don't write log base e on the test as your final answer. Instead, write ln 15. So, part A, example 3, part A, final answer is x equals ln 15. Any questions on part A in particular, how to get x equals ln of 15? Pronounced natural log of 15. Okay, try part B on your own then, starting with the codes OE, A4, and LF. Try it. I'm just going to tour the room, see how you do on part B. When you multiply by 2, you get 2 natural log 10, which, by the way, can also be written as natural log 100, because 2 is a hat that can go on top of 10 to turn it into 100. Notice how I got 2 natural log 10? I just did an M2. M2 gives you 2 natural log 10. Try part C on your own if you don't mind. Part C. Go straight into log form. When When you're done, take a peek at the board for part C. Then go on to part D. Using S1, D2. Now, if you write it 1/3 natural log 4, we'll give it to you. But others of you might end up writing it as natural log of the cube root of 4. Same thing. Both of those are full credit answers. So were there any other questions? Owen, I know you had a question earlier.
I forgot.
You were gonna ask, is this gonna be on the test?
I forgot. Wow.
Yeah, you were wondering whether 2.7 Andrew Jackson isosceles right triangle was gonna be on the test. Do you remember when you had that question?
9.
Yeah. Really, all you need to know is the 2.7 Andrew Jackson part. And that's enough. That's all you need. All right, homework's due tomorrow, a block day actually. Have a good afternoon.